Hey yo, what's up, YouTube? It's your boy JOSHADARAHAM. Is your back to back two-time winner. Ciao. Exercise sheet 11, winter semester. Electrolyte solutions and equilibrium electrochemistry. That's what a normal person's reaction would be. But you know me, I take that shit. Biochemical Kinetics assignment. I also saw that there was something else on the website, on the assignment upload site. There is something else. Let me go check it out. Let me go check that out. Oh man, I got scared. I got scared real bad. Oh, that was exercise 11. Yeah, this is exercise 11, yeah. Handout electro. Oh, that was just the definition. Okay, that makes sense. That was just some definition, boy. That was some teensy weensy wincy definitions. I'll show you. This was it. Handout for electrochemistry definition. Electrode where oxidation occurs, cathode where reduction occurs. Wait, let's read the first question. It's a lot. We got 1 hour, right? So is that time for 30 minutes? A student determined the acidity of succinic acid. Bernsteinsäure. Bernsteinsäure? Ja, genau. Bist du sicher? Jo. In a lab course through conductometry, the conductometer was calibrated with an aqueous sodium chloride solution, a solution of 0.7456 grams. Look at the numbers, 0.7456 grams of sodium chloride in 100 milliliters deionized water showed a conductivity of 12.04 into 10 raised to minus 3 second? No. Conductivity as a new unit? What is that unit? In a separate flask, a succinic acid stock solution was prepared. Its concentration was determined through titration with a 0.0929 mole per liter sodium hydroxide titrant. 5 milliliters of succinic acid stock solution consumed 18.05 milliliters tyrant. Then the stock solution was diluted by factors of 5, 25, 125. What? I'll be right back. Oh shit, that was too much data. I need some music. Falling, dreaming, talking in your sleep. I want you to cry all night. Honestly, plotting, scheming, talking. Uh, its concentration was determined through titration, but 5 milliliter of succinic acid stock solution consumed 18.05 milliliter titrant. Then the stock solution was diluted by the factor of 5, 25, 125. We're talking milliliters? 0.10 milliliters. Stock solution was titrated with 36.13 milliliter titrant until equivalence point. The resulting stock was then diluted to 200 milliliters with deionized water to yield the sodium succinate stock solution. This sodium succinate stock solution was diluted by a factor. Finally, the conductances were measured from both the stock and diluted solutions. Wait, what? Wait, what? What? Say what? Dude, I need to learn a lot about this. Well, wait. I don't know if DeepSeek has some weird shit up there. No, okay. I got scared, okay? I got scared. Mm, mm, mm. All right, let's carefully. You have a conductometer that was first calibrated using NaCl. This allows you to determine the cell constant G. What's a cell constant? Succinic acid is prepared, titrated with NaOH, then diluted and measured for conductance. Using the conductance data, you are asked to determine cell constant molar conductivity at infinite dilution of the first dissociation stage. Oh, come on. 15 minutes? Come on, come on. Bring it up. Crank it up. Crank it up. Using the conductance data, you are asked to determine the cell constant molar conductivity at infinite dilution of the first dissociation stage. Oh, a lot of terms. Degree of dissociation and acidity constant for the first proton of succinic acid. Step A, cell constant. Concept: cell constant relates measured conductance L to solution conductivity, where C is in per meter, K is the known conductivity of the standard solution, G is the measured conductance of that solution. Reasoning. It does not have the cell constant. Could you explain how the problem is how like what is happening first? What are the things we should find? And also explain the terms involved. I don't know what cell constant, at least not. So could you also explain what's happening in this experiment? This is a conductometric determination of the acidity of succinic acid. Conductometric determination of conductometric determination of acidity of succinic acid. So we're basically trying to find the pH, I believe. Combined with titration information, the first student oh, there is a student calibrates the conductometer using known solution of NaCl. This determines the cell constant, which accounts for geometry of the electrodes, distance, area. Then the student prepares a succinic acid stock solution and dilutes it. Okay, the conductivity of this solution is measured. Conductivity depends on the ions in the solution, which in turn depends on the degree of dissociation of the acid. Okay, using this data, the goal is to find the cell constant, a factor to convert measured conductance into true solution conductivity, molar conductivity at infinite dilution for the first dissociation of succinic acid, degree of dissociation and first acidity constant for succinic acid. Important terms in the question: cell constant, a physical property of the conductometric cell, accounts for electrode area and distance between the electrodes, converts measured conductance to C times G. Measured conductance to actual. A student determined the acidity of succinic acid in a lab course via conductometry. The conductometer was calibrated with the aqueous solution and chloride solution. A solution of 0.7456 grams of sodium chloride in the 100 milliliter deionized water showed a conductivity of 12.04 into 10 raised to minus 3. What's with the unit? So that's the solution of sodium chloride in 100 milliliter deionized. So there are some formulas. Conductance G versus conductivity. Conductance measured directly by the instrument Siemens. Conductivity, a property of the solution itself, depends on the cell. Independent of the cell. This sentence now what does the Devoto did. Hi. Appreciate Devoto did for checking out the stream. Hell yeah. What the sentence says: a solution of 0.7456 grams of sodium chloride is 100 milliliter deionized water showed a conductivity. Okay, we're preparing a solution. It's gonna be NaCl, salt dissolved in water. NaOH, HCl, equilibrium, kinda, I believe. Measured conductance. Siemens is the unit of conductance, which how easily electricity passes through the solution. Okay, that depends on the ions formed. Conductive molar meaning of the conductivity. I was meaning molecular, okay? Conductivity is how well the solution can carry electricity on a molecular scale. NaCl dissolves into ions, okay? Electric current in the solution is carried by these ions moving under an electric field. These ions The more ions percent, the faster they move, higher the conductivity. The conductivity depends on the number of ions, so the number of NaCl here, mobility of the ions, how fast the ions can move in the electric field. Mhm. Temperature and viscosity of water affects ion mobility. If it's a hot water, more conductivity. In the separate flask, a succinic acid salt was prepared. The concentration was determined via titration with the sodium hydroxide titrant. 5 milliliter of succinic acid stock solution consumed for 18 point. Um. Now, when you say titrant, I my mind is not registering. What does titration do? Come on, little guy, think. Then the stock solution was diluted by the factor of 5, 25, 125. So I believe from this titrant stuff, we have to calculate how much succinic acid was prepared. Then the stock solution was diluted, okay. Thereupon, 10 milliliter of stock solution was titrated with 36. Again, there's titration coming up. The resulting solution was diluted to 100 milliliters with deionized water to yield as a sodium succinate stock solution. Yeah, right. Stream live on 24th of December. It's officially 1 year. 1 fucking year. Hell yeah. It's been 1 year of the channel. Oh. 1 year? Yes, 1 year. We did it. That's crazy. 1 year, 1 year. Would I say I have a lot of improvement? Yes, I did have a lot of improvement. But I'm still struggling with focus. I'm new and this is my streaming day too. Mm-hmm. Electric current in solution is carried by these ions moving under electric field. The more ions present, faster they move, higher the conductivity. So conductivity depends on number of ions. The more Na plus and Cl minus, higher conductivity. Mobility of ions. Fast the ions can move in the electric field, temperature and viscosity of water affect ion mobility. Wait, wait, wait. Number of ions, Na plus, higher conductivity, mobility. Okay, I get that. Okay. So, uh, I understood that conductivity was 30 minutes. Push up. What happens in this part's a kinetic. Oh, dude, I need some bread. Let's reset a time for 30 minutes. That's a tool. Titration is a lab method used to determine the concentration of unknown solutions. Yes, it's coming back. It's coming back. What happens in this part? Succinic acid stock solution was prepared, titrated with an AOH. Succinic acid is a diprotic acid. It can donate 2 protons. Okay. You have a stock solution of succinic acid with unknown extract. You slowly add NaOH of known concentration until all the acid is neutralized. Okay. But here concentration was with. Okay, here again. Sodium hydroxide, sodium chloride. Okay, okay. Titrant 5 milliliters of succinic acid stock in solution consumed. Then the stock solution was diluted by factors of 5. Okay. So point of neutralization equivalence point at this point, number of moles of base added exactly equals to the number of acidic protons. Okay. Why is titration needed in this problem? Later on, you realize measure conductivity of the succinic acid and sodium succinate solution. To interpret conductivity data, you must know the concentration of succinic acid in the solution. So in a separate flask, its concentration was determined through titration with the. So this is the concentration of the sodium hydroxide solution, and 5 milliliter of succinic acid stock solution consumed 18.5. Okay, now I need a. There's 2C. Okay. Uh, then stock solution was diluted by the okay. Here are we talking about the succinic acid being diluted first with thereupon 10 milliliter of stock solution were titrated with 36 point okay using equivalence point. The resulting solution was then diluted to 100 milliliters of deionized water. So this 10 milliliter of succinic acid was diluted to yield the sodium. No, we're it does have sodium in it. What? Okay. Thereupon, okay, here at first I thought this sodium succinate stock solution was diluted by the factor of 5. Finally, the conductance were measured from, okay, so first had it 100 milliliters, then 500 to 50, no, 2500. Exactly. At this step, 10 milliliter of succinic acid stock was titrated. This means all the acidic protons from the first dissociation step reacted with NaOH. The resulting solution now contains sodium succinate, the conjugate base, instead of free succinic acid. Then this reaction mixture was diluted with to 100 milliliters with deionized water to make a solution, sodium succinate stock solution. So the dilution here is after neutralization, not just diluting succinic acid alone. It's after neutralization. The stock solution later further diluted by the factor of here we are increasing the volume so this is the conductivity. Why are we using KCl? It's like a standard. Not quite. The dilution factor doesn't necessarily mean those exact volumes of water. It's a ratio of total volume to the original solution. So original solution would be from this original sodium sulfate solution. Ten, 46 plus 100. Mm-hmm. Mm-hmm. So this 46. Uh, volume contraction or mm-hmm. Now Fantasy PMO with an O. What's up, gang? What's up? I apologize for the late seeing your shit. Interesting. $14. Come on, crank it up. Exactly, KCl is used as a standard electrolyte to determine the cell content of the conductometer. Since its conductivity of a known concentration is Known from literature, you can use it to calibrate the instrument. Regarding the values, the number are given in Siemens. The negative exponent just reflects the small values. It doesn't mean negative conductance. As the soluble solution is diluted, conductance decreases. Okay, because fewer ions per unit volume. So the conductance decreases with dilution, which is constant with which is consistent with expectations. Okay, now it's not a filler. It provides raw data needed to calculate the sin constant. Key formula for cell constant K known. It's the literature conductivity of the standard. Here, zero point 0.1 m all of NaCO. G measured is the measured conductance in your experiment. Zero point 0.1 mole. Where did you get this one, bro? Where did you get this, brother? Okay, these values are not related. Okay. Mm-hmm. What did DeepSeek do? What did you do, bro? Calibration, dilution, still constant. Let's see if they got the correct answer. Because if they don't, I don't think I should be moving forward. Mm-hmm. Let me take a piss. Be right back. I should stop smoking. I need to eat something. I think my body is starting to reach its limit. 6 minutes, okay. Fantasy PMO, Devoto did. I'm gonna refresh the chat because it's a bit too much. Was it given though? Where did you get this, bro? I think we have to. Uh, Uh, use a commercially OBS crashed. Oh shit. OBS, you just did not crash. 48 seconds. Oh man, I'm tired. Not gonna lie, I'm pretty tired. Yes, you can use the KCL solution data from the table as your reference to calculate the cell constant. Here's how. Come on, do it. Oh, it's still the same. OBS crashed again. OBS crashed again. I think it's introducing the. A lot of stuff in the bin. Empty. Bin is empty right now. That's good. 198, yes. Cell constant K is given by K by G. G is measured conductance of the solution. True conductivity of the solution. So, okay. G is the measured conduct. Okay. Could you conductivity of the solution. This is an intrinsic property of the solution independent of the measurement cell. Conductance measured by the conductor. This depends on the solution and geometry of the cell. Okay. So the K value, the small k depends on the solution. The G depends on the solution and the cell. The unit of G is Siemens. The unit of K is Siemens per meter. So it's per meter. Cell constant is per meter. So the cell constant has units of meter, but it's basically geometry factor length by area of the electrode. So KCl was used at the standard. No. So KCl, what does this value by KCl mean molecularly that we took as standard? Like, how does this value represent, or what does this value? So that was taken as G. Now, what's the K? It's 1.29. Conductivity from, again, we use the literature. Why? Why? 'I think this sentence than using the literature value for one hour to even start a question. Damn, that's taking a lot. What measured mean molecularly? Conductance is to measure how easily electric current can pass through a solution between two electrodes. I thought the cell constant was also referring to that. Molecularly, an HCl in water depends on the number of ions in the solution, their mobility, how fast they move under an electric field, distance between the electrodes, and the cross-sectional area of the solution between them. You know what? I'm in the stream. I gotta cook something. I eat something real fast. We continue with sequence analysis. Then we come back again. But keep in mind, general chemistry still exists. Peace out, YouTube.